Okay, here we go with the last notes for this chapter. Notes number 11, represent functions as graphs. Put your name, date, and period on this, and then your essential question is how do you represent functions as graphs? And this is just plotting the points on a coordinate plane and drawing your line or not drawing your line based on the situation. Graphing a function, it says you can use a graph to represent a, did I forget something? Represent a function. Forgot the word function on there. It says in a given table, each corresponding pair of inputs and output values form an ordered pair that we're going to look for. And then an ordered pair of numbers is plotted as a point on our graph. So a point. And then the x-coordinate is going to be the domain, which is our independent value. Then the y-coordinate, which is opposite of domain, is the word range. And the opposite of independent is dependent. Okay. The horizontal axis of your graph is labeled with the independent variable then the vertical axis will be labeled with the other one, which is the dependent variable. Okay, so we're going to graph the function, for example, number 1. It says graph the function y equals x plus 1 with a domain of 1, 2, 3, 4, 5. So in my table, I'm going to do 1, 2, 3, 4, and 5. If I'm thinking about it, doing my mental math, if I do plug in the 1 for x, that's 1 plus 1 means my y would be a 2. And then let me change colors. That would be a 2. And then if I plug a 2 in, 2 plus 1 would be a 3. And if I plug in a 3, 3 plus 1 would be a 4. 4 plus 1 is 5, and 5 plus 1 is 6. Okay. Then I want to plot these. Realize this together is one of my coordinates. So I'm going to have the coordinate, the 1 and the 2. Whoa, my paper slid. From this value. And then my next coordinate is going to be a 2, whoops, and a 3. And then your next one, if I can write these correctly, will be a 3 and a 4, and then a 4 and a 5, and then a 6, if I can slide this out of the way, a 5 and a 6. These are all my coordinates that are coming from the table in that fashion. I'm going to transfer these to my graph. 1, 2, if I slide this up so you can see it, is located in that graph, where this represents my x values and here is my y values. The ordered pair, the first one is your x's, the second one is your y. So these all represent my x values. The second column represents my y values. There's my first point of 1, 2. The next one is 2, 1, 2, 3. Next one is 3 and 1, 2, 3, 4. 4 and 1, 2, 3, 4, 5. 5 and 1, 2, 3, 4, 5, 6. Okay. Now, since I was given a domain to use, they didn't just tell me graph the line. I do not connect my dots. I just have my dots on my graph. When I just have dots, this is called a discrete function. It's very, very important. Discrete functions only have dots on your graphs because it is a limited domain. Okay, on example 2, I have the graph. It says write the function for a graph. Write the function rule for the graph represented by the graph. Identify the domain and range of the function. Well, first thing I want to do is make the table. I want to pull the points off. Notice there's a point down here at the bottom. The coordinates are 2 and it doesn't go up at all, so that means it is a 0. The 4 goes up only 1 unit, so that's a 1. 6 goes up to a 2. 8 goes up to a 3, and 10 goes up to a 4. Alright, we've got to identify the domain and range. Okay, to find my equation, I'm going to go back to my calculator and I'm going to reset it. And let me clear that off. I'm going to go back into Stat. Remember your buttons from yesterday. I'm going to edit, and here's my L1. I'm going to enter in 2, 4, 6, 8, and 10. Okay, so I have all those. I'm going to right arrow to get to the second column, and I'm going to enter 0, 1, 2, 3, and 4. So I have my 2 columns. Make sure I have one for each number. I'm going to go back into Stat and over to Calculate, and I'm going to go down to the 4th one and enter, and then enter all the way through the word Calculate so I can get my actual expression. So that here, find the relationship between the inputs and outputs. That means I have, if I'm looking at my equation, I'm going to put 0.5 in for A and a -1 in for B. So if I'm looking at this to start out with, it appears to be 0.5x plus -1. Now, this is the way the calculator is giving us our equation. There is one important thing you need to realize, is this value is never going to be written as a decimal. So I'm going to change this to 1/2. And then this needs to change because we don't want a plus a minus. This is actually just going to be a -1. So my actual relationship is going to be y equals 1/2 x minus 1. The y and the x are always there because our graph has an x and a y value. That's where the x's and the y's are coming from in your equation. Here it is written in verbal form. Each output value is 1 less than half the corresponding input. So half the corresponding input is your x's. Less than means you're subtracting and you have a 1. Okay, so on number 3 we wrote our equation up there at the top, 1/2 x minus 1. The domain, put your little ellipse, will be 2, 4, 6, 8, and 10, and then the range will be the other numbers 0, 1, 2, 3, and 4. Okay, we do not have any independent practice problems because you have to use the calculator for this, so you'll get your practice problems in class, and this is a little more difficult, so you may have to play this several times to understand it. I'll see you in class.